Two points in 3D space are given as P is the point 1, 3, minus 1, and Q is the point 2, 4, minus 3. We're asked to find the parametric equation of the line that passes through the points P and Q. Well, first of all, we want to get the position vector A. Position vector A. And A looks like this. We get the 2 from here, from the first element of Q, and we subtract the first element from P, which is 1. Then we get our 4, our second element, and we subtract the 3, the second element of P. And then we get our minus 3, and we're going to subtract, be careful now, our minus 1. So that gives us 2 minus 1 is 1, 4 minus 3 is also 1, and that's going to be minus 3. It's going to end up being minus 3 plus 1, so that's going to be minus 2 in there. Now we can call P our vector R1 like this: 1, 3, minus 1. And then the parametric equation is given by the following. Vector R equals R sub 1 plus T times A. So we sub in R sub 1 there is 1, 3, minus 1 plus T times 1, 1 and minus 2, because that's A from up here. And what do we do with that? We tidy that up then. So tidying that up, we get 1, or we get 1, we can leave that there for a minute. Then multiply in the T, we get T, comma T, and there should be no bracket there, comma minus 2T. So tidying up the elements, it's going to be 1 plus T, comma 3 plus T, comma minus 1 minus 2T. And so this is our parametric equation. That's it there, right? And now, so the next part then. Now we're asked to find at what point does the line found in part 1 intersect the YZ plane. Well, it'll intersect, the line will intersect the YZ plane when the x component equals 0. So we set that equal to 0. So we take the x component is that bit there, 1 plus t. 1 plus t equals 0. So then t, we take away 1 from both sides. T equals minus 1 when the line intersects the YZ plane. So all we need to do then is complete to get the point. Then the point is capital R there. So R is going to be equal to 1 plus t, but t, remember, is minus 1, comma 3 plus minus 1, comma minus 1 minus 2 times minus 1. So we're just subbing in minus 1 wherever t was. So this gives us 1 plus minus 1 is going to be 0 for the x component. 3 minus plus minus 1 is going to give us 2 for the y component. And the z component, minus 2 times minus 1 is going to give us a plus 2. So it's going to be minus 1 plus 2. That'll give us a positive 1 there for the z component. So that there is the point where the parametric line intersects the YZ plane. Now next up there we're going to do part 3. Calculate the area of the triangle with vertices or corners at PQ and the origin there. Right, the handiest way we're going to do that, the area of a parallelogram, you see, if you had vectors with sides u and v, the area of that parallelogram would be equal, the area of that parallelogram, if you see it in the formulas in the back of the exam paper, the area of that parallelogram would be the cross product, and then we get the size of the cross product. So that's done. How's that done now? I have the formulas open here on another screen, right? So U cross with V, this is the formula, right? You get this IJK thing going on here, and we'll be putting in the bits and bobs here. You know, you'll be loading up. We'll see it now in a minute. It's really handier to show it with the numbers, right? And that'll be I. There'll be 4 items here, minus. There'll be 4 items in this structure. See, that's a minus there between them, and then plus for the last one. 4 items here, and the K, right? So for us, we're going to get the cross product of the P and Q vector there. So we'll have our I components, J components, and K components. And it's going to be 1, 3, minus 1. That came from P there. And the Q then will be 2, 4, and minus 3. So when it comes to loading up this I bit here, we ignore the I column and we just use the other bits, 3, minus 1, 4, and minus 3. Then we're going to have a minus, and we're going to have 4 items in front of J. So we ignore the J column this time, so the first column there will be 1 and 2. Then we'll take this minus 1 and minus 3. Then we have plus K, and then we'll ignore the K column, so we'll be taking 1 and 2 and 3 and 4. And then we'll work out these 3 bits, so we'll have a big bracket here. That'll be 3 times minus 3. So you have to be careful with your signs here. Minus the product of the other diagonal. So that's going to be 4 times minus 1. Close your bracket. That'll all boil down to give you the I component. Minus, open another bracket. The product, we're going to have 1 times minus 3 minus 2 times minus 1. Close the bracket. That's our J component. And finally, similar process here, 1 times 4. I know it's 4, but I'm just going to stick to a kind of a systematic method. That's your best bet, especially in an exam. You might be suffering from a few nerves, right? So now we need to just clean up those guys, taking care with our signs. I'll just bring up some extra screen there. So we keep our big bracket. 3 minus 3 is minus 9. Then we're going to have 4 times minus 1 is minus 4. Minus that is going to give us a plus 4. That's going to be in front of our I. Then 3, that's going to be minus 3 there. So again, we have 2 minuses here, so we're going to end up with a plus 2. And then we have 1 times 4 is 4 minus 6 times K. So that becomes, the bigger number here is minus, so our answer is going to be minus. The difference between them is 5. Here again, we're going to have negative 1, but then we have another negative sign here, so that becomes plus 1J. So we can leave out the 1 and just have plus J. 4 take away 6 is minus 2. Minus 2K. Now, at the start I said that the area of a parallelogram, didn't I? You know, 2 vectors crossed like that and get the size of them. That's the area of a parallelogram, but we're not getting the area of a parallelogram. We're getting the area of a triangle. So it'll be half this, half multiplied by the cross product of P and Q. The size of the cross product, the value, the size of it, right? The magnitude. That'll be equal to the area of our triangle. So we're getting the size of this guy now. The size of P dash Q, or P cross with Q, the magnitude will be just like this. We get the square root. We get minus 5 squared plus 1 squared plus minus 2 squared. And that gives us root 25 plus 1 plus 4. So that's going to be the square root of 30. That's the magnitude. The square root of 30 is the magnitude. And then we just have to multiply that by, that's the magnitude of the parallelogram. You could be asked for the parallelogram and you'd stop there. But because we're asked for the triangle, the area of the triangle will be equal to half multiplied by the magnitude of the cross product of P and Q. Right, so that's going to be equal to a half multiplied by root 30. And we can bang that into the calculator and get a decimal version of that. So I 0.5 multiplied by root 30. And I get, first of all, it spits out root 30 over 2. And if we convert that to decimal, we get 2.738 and so on. Set to 2 decimal places, then 2.74 units square because it's area. And that's your area of your triangle formed between them two vectors and the origin.